Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2024 from topic Central Force and Central Orbit. Here in the question, a particle moves with a central acceleration mu times of 3 upon r cube plus d square upon r5 being projected from a distance d at an angle 45 degree with a velocity equal to that in a circle at the same distance. Prove that the time it takes to reach the center of force is d square upon root 2 mu bracket 2 minus of pi by 2. Let's solve the problem. Given central acceleration is this is p is equal to mu times of 3 upon r cube plus of d square upon r की power 5, and we know that here we can write that is we can also that is mu times of 3 u cube plus of d square u की power 5 because u is equal to 1 by r in the central orbit. Further, the angle is given by theta is equal to 45 degree, and further we have to let v be the velocity at a circle let v be the velocity at a circle at same distance under the same acceleration is given by v square upon d is equal to p, and here is r is equal to d. So we have to put the value of p, that is mu times of 3 upon, in place of r we have to put d, that is d cube plus d square upon, in place of r we can also put d, that is d5, and from here d square to d5 is cancelled out, remaining is d cube. Further we have to solve, that is mu times of 3 upon d cube plus and 1 upon d cube. Taking LCM here, d cube is LCM and 3 plus 1 is 4. So we have to get 4 mu upon d cube, and from here d cube to d is cancelled out and the remaining is here d square, and from here it is v square is equal to 4 mu upon d square, and v is equal to 2 root mu upon d. This is the value of v. We can also write here, that is the value of v is 2 root mu upon d. Further we have to solve. Differential equation of central orbit is given by d2u upon d theta square plus of u is equal to p upon h square into u square, and we can also write this differential equation of central orbit. H square is cross multiplication with this function, that is h square d2u upon d theta square plus of u is equal to p upon u square, and here we have to put the value of p, that is p is given by mu times of 3u cube plus d square u की power 5 upon u square. Further we have to solve, that is h square bracket d2u upon d theta square plus of u is equal to, here from numerator we have to take common u square, that is mu into u square, and here is remaining 3u plus of d square and into u cube upon u square, and from here u square to u square is cancelled out, and the remaining is h square bracket d2u upon d theta square plus of u is equal to, here is mu into 3u plus d square u cube. Further, the above equation multiplied with multiplying both the sides by 2 du upon d theta and integrating. First we have to multiply this given equation with 2 du upon d theta, then integrating, that is equation becomes, that is h square, and here is 2 du upon d theta and d2u upon d theta square plus of, here is u multiplied with 2 du upon d theta, that is 2u du upon d theta is equal to, here is mu is taking outside, and 3u multiplied with 2 du upon d theta and plus of d square and d square u cube multiply with 2 du upon d theta. Further we have to write in the differential form, that is derivative form, h square into, here we can write 2 du upon d theta, d2u upon d theta square is written as dy d theta of du upon d theta का whole square. When du upon d theta the whole square differentiating with respect to theta, that is 2 du upon d theta, and again du upon d theta differentiating with respect to theta, we get d2u upon d theta square. We get the above result, so we can write here, and further 2u du upon d theta is written as d by d theta of u square. Again u square differentiating with respect to theta, that is 2u, and again u differentiating with respect to theta, that is du upon d theta is equal to mu, and similarly we can also write, that is 3 and 2u du upon d theta is written as d by d theta of u square plus of, here 2u cube du upon d theta is written as d square upon 2 and d by d theta of u की power 4. When differentiating v की power 4 with respect to theta, that is 4u cube and du upon d theta, when dividing 2, that is get 2u cube du upon d theta. And further we can also write, that is once again further the given differential equation is written as h square, and this is integration is the inverse process of differentiation, so we have to write here du upon d theta का whole square plus of u square is equal to, here is mu square plus of d square upon 2, here is u की power 4 plus of a, taking constant when integration. Further we have to know that velocity is given by in central force. We have to let this in equation 1, and velocity is given in central force, that is v square is equal to h square and du upon d theta का whole square plus of u square. This is the equation of velocity, and we can from here this is equal to h square du upon d theta का whole square plus of u square, and we can also let the equal to v square. This is equal to v square. Further, this is equal to v square, and further we have to solve. We know that in the Peter form of the central orbit, that is p is equal to r sin theta, sorry, and here r is equal to d, so we have to put here r is equal to d sin theta, and p is equal to d and sin theta. We get the theta is equal to 45 degree. We have to write here sin 45, and the sin 45, the value of sin 45 is 1 upon root 2, so we have to write d upon root 2. And we know that the equation of pedal form in the central orbit, that is pedal form of central orbit, that is we can also write 1 upon p square is equal to du upon d theta का whole square plus of u square. And from here we can put the value of p here. When putting the value of p, that is once again on squaring here, that is p square is equal to d square upon 2, and we have to write 1 upon p square, that is 2 upon d square, and du upon d theta का whole square, du upon d theta का whole square plus of u square. Further we have to put, and the velocity is given by here, that is 2 root mu upon d. So we have to put here once again, we can put here, that is in the velocity equation of the central orbit, that is v square is given by, that is 4 mu upon d square is equal to, here is h square and du upon d theta का whole square plus of u square is given by 2 upon d square. We can write here 2 upon d square, and from here d square to d square is cancelled out, and 2 to the 4, and the remaining is here h square is equal to 2 mu, and we can also write that is h is equal to root of 2 mu. We have to write here that the value of h square is 2 mu, and h is equal to under root of 2 mu. Further we have to find the value of constant a. Constant a we have to find. We know that v square is given by 4 mu upon d square is equal to, we have to take equal to mu into 3 u square, and here we can, on finding the constant a, we can let that is u is equal to 1 upon d, and r is equal to d also. So we have to put here 3 by d and plus of d square upon 2 here u की power 4, that is 2d की power 4 and plus of a, and from here d square to d की power 4 is cancelled out, that is d square. Further we have to solve that is 4 mu upon d square is equal to, here is mu, once again here is mu and 3d, once again 3 upon d once again 3 upon d square, here u is equal to 1 by d, this is 3 upon d square and plus of 1 upon 2d square plus of a. Further we have to solve, we can write here that is 2 upon d square is equal to du upon d theta का whole square plus of u square. Further we have to using the result, and we can also take mu of 3 mu upon d square and mu upon 2d square into left hand side, that is 4 mu upon d square minus of 3 mu upon d square and minus of mu upon 2d square is equal to a. And we are on solving this, taking LCM is 2d square and from here that is 8 mu and d square that is minus of 6 mu, and from here 2d square, LCM is 2d square and here is mu. So we have to get the value of a from here, that is minus of 6 mu and mu, that is minus of 7 mu, and 8 mu minus of 7 mu, that is mu upon 2d square. This is the value of a. We have to write here, that is the value of a is mu upon 2d square. So we have to put the value of a and h in the equation 1. Putting the value of h, that is h square is given by 2 mu and du upon d theta का whole square plus of u square and is equal to mu, and here we can write that is 3u square plus of d square upon 2 u की power 4, and the value of a is given by mu upon 2d square, and we have to put here that is u is equal to 1 by r, and we can also find the value of du upon d theta from here, that is minus of 1 upon r square dr upon d theta. We have to put the above equation, that is 2 mu, and we can also once again 2 mu and this is du upon d theta का whole square on squaring du upon d theta, that is 1 upon r की power 4 dr upon d theta and plus of, in place of u square we have to put 1 upon r, that is 1 upon r square, and is equal to, from here mu is taking common, that is mu is taking common, then the remaining is here 3 upon r square, mu is equal to 1 by r, so we have to put u is equal to 1 by r, that is 3 upon r square plus of d square upon, here is u की power 4, so we can write that is 2 r की power 4 plus of 1 upon 2d square. From here mu to mu is cancelled out, and further we have to take, once again, mu to mu is cancel out. Mu to mu is cancel out, then the remaining is 2 times of 2 upon r की power 4 and dr upon d theta plus of 2 upon r square is equal to, here is 3 upon r square and plus of d square upon 2 r की power 4 plus of 1 upon 2d square, and we have to take, we have from here we can take, that is 2 upon r की power 4 dr upon d theta is equal to 3 upon r square plus of d square upon 2 r की power 4 plus of 1 upon 2d square, and plus of 2 by r is taken into right hand side, that is minus of 2 upon r square, and from here we have to take a LCM. Take a LCM here, that is LCM is 2 r की power 2d square r की power 4 is the LCM, and here is 2 upon r की power 4 dr upon d theta, and from here remaining is r square, that is we can write here 3r square and d square. Once again, here is r square, that is we can write 2 d square r square, so we have to write here, this is 6 r square and d square plus of, from here 2 r की power 4 is present, d square is not present, that is d की power 4 plus of, here 2d square is present, then 2d square is present here, then we have to write, that is r की power 4 and minus of, here r square is present, so we have to write here minus once again 2 is already present and r square is present, so we have to write 2d square r square, that is 4d square r square, and further we have to solve, that is 6r square d square minus of 4d square r square. We can also write, first we have to write r की power 4 plus d की power 4 and 6r square d square minus of 4d square r square, that is minus plus of 2 r square d square upon, this is 2 d square r की power 4, and from here we have to cancel the terms r की power 4 and the remaining is here, that is 2 dr upon d theta is equal to, we can also write these terms r की power 4 plus d की power 4 plus 2 r square d square is written as r square plus d square का whole square and upon is given 2d square. 2d square, once again 2d square is present, and from here we can also once again 2 dr upon d theta, 2 is taking here. Further we have to also know that we can also write 2d square, taking LCM is, and here is 2d square, and we know that is r square d theta upon dt is equal to h, and further we can also write, that is r square d theta upon dr into dr upon dt is equal to h. Further we have to put the value of dr upon d theta, so we have to write here once again 2 upon dr upon d theta, and we have to find 2 upon d square. Once again, we have to find from here dr upon d theta is 2 is taken into denominator, that is r square plus of d square का whole square upon 4d square. So we have to put here, that is r square into, we have to put d theta upon dr, that is 4d square upon r square plus of d square. Once again, d theta upon dr, r 4d square upon r square plus d square का whole square, and here is dr upon dt is equal to h, and further from here we can also put the value of h here, that is h is given by, once again we have to take common, that is from here, that is 4d square, and we can write r square upon r square plus d square, and this is dr and h dt. So we have to put the value of h here, that is root 2 mu, the value of h, and from here is dt, and further we have to integrate with d to 0 here, distance is d, and this is given by 4d square, and from here we can also write once again r square is taking common, this is r square upon d square, and we can also write the given integration in terms of, that is d to 0 and r square plus of d square minus of d square upon r square plus of d square into dr is equal to, here is root 2 mu, and integration of dt is t, and we have to find the value of t. So we can write here, that is t into root 2 mu is equal to, here we can take r square plus d square in one, and second minus of d square upon r square upon d. We can write, that is 4d square is taking common first, and integration of d to 0, and we can write, that is, first we have to write r square plus of d square upon r square plus d square, it is 1 minus of d square upon r square plus of d square, and here is dr. On further integration, that is t root 2 mu is equal to, here is 4d square is common out, and on integration of dr is r, and minus of here d square is taking common once again, and from here 1 upon r square upon d square is given by, we know that the integration dx upon a square plus of x square is given by 1 upon a tan inverse of x by a. So we have to put here, that is 1 upon d, and tan inverse of, here is once again x by a, this is 1 by a, this is x by, that is r upon d, and putting the limit, that is d to 0, here is d to 0. Further from here d to d is cancel out, remaining is here d. So 4d square, and from here r, integration of dr is r, that is r minus of, here is d, tan inverse of r upon d. And so we have to put the value of, first we have to put the upper limit, we get the total 0, and we have to put the lower limit, that is t root 2 mu. We put the lower limit, that is minus of, once again here is 4d square. 4d square is present. Here we have to put the lower limit, that is minus of d minus of d tan inverse of, here in place of r we can also put d, that is d upon d, and this is t root 2 mu, and further we have to solve, that is 4d square, and from here we have to take common, that is d. Once again, this is minus is taken into outside, and d is taking common, that is this is d cube, and here is 1 minus of tan inverse, from d to d is cancel out, and the value of tan 45 is 1. Tan 45 is written as pi by, once again, 1 by tan inverse of 1. This is equal to tan 45 is tan 90. The value of tan 90, once again, pi by 2, the value of tan 45 is tan 90. The value of tan 90, that is, the value of tan 90 is 1. Tan 90, once again. And from here we can also t root 2 mu is equal to, here is 4d cube and 1 minus of, the value of 1 is tan 90, 1 minus of pi by 2, 1 minus tan 90, once again, tan 45. The value of 1 is tan 45. Tan 45, that is 1 by 80 upon 4, that is 4 4s are 16, and here is tan 45. Tan 45, that is pi by 4. This is pi by 4. The value of 1 is tan 45 is 1, and further we can also prove, that is t is equal to d square upon 2 root mu. We have to prove t square is equal to, from here we can, t is equal to minus of 4d cube upon root 2 mu, and here is 1 minus of pi by 4, and we have to arrange this step once again. When we have to take lower limit, this is equal to minus, and minus is already present, that is minus minus is plus. So here we have to get a plus, minus is removed on applying lower limit, and further we have to also write, that is d cube. We can also write, that is 2 is taken into the bracket, that is 2d square upon root 2 mu, and 2 minus of pi by 2. This is the required proof, and this is the required solution of the given problem. D cube, once again we have to some mistake in D cube. D sin theta d upon root 2. Here is not D cube, this is D square. And when taking 2 is in the bracket, we get the above result. 2D square, again we have to not get 4 here. 2 minus of 5 by 2. Thank you class and thank you for watching. 10:45.